All right, so section 8.2 is on circles. This is a pretty easy, like the easiest of the conic sections. It's really not that bad. Most of it you should remember from geometry. You laugh, I know. So a circle is a set of all points in that are a fixed distance, called the radius away from a fixed point, called the center. So I'm going to show you how we came up with the equation of a circle. Okay, so we're going to sketch this out. We're going to have a center at -3, 4. I don't know why I drew it way up there. And then a radius of 6. So we're going to go up 6, left 6, right 6, and so on. And we draw a circle in. Oopsie, missed it. Okay, so there's my circle. Okay, this circle should be 6 units away from any point that's along the edge of the circle. Okay, so my center was that -3, 4. But any point along the edge, we just write as x, y. We're not sure what that is. Okay, so if I come up with an equation using the distance formula, we know that the distance is x2 minus x1 squared plus y2 minus y1 squared, all under a square root. And this is going to be my set x2, y2, my x, y. And this will be my other point, my x1, y1. So when I plug it into my equation, I'm going to have x minus a -3 squared plus y minus 4 squared. So I end up getting x plus 3 squared plus y minus 4 squared. Oops, and it's really equal to my radius, right? So instead of d, I'm going to write r. That's my radius. What is the radius in this case? 6. Let's put 6 there. Okay, and I don't want it to be so complicated looking. Whenever they throw a square root in there, it just looks so much harder than it really is. So what I'm going to do is I'm going to square both sides. So I'm going to end up with x plus 3 quantity squared plus y minus 4 squared equals 6 squared, which is 36. Okay, can you see all the pieces of the circle? Did you guys see how our center was -3, 4? Where is that located? See how it was x plus 3 and y minus 4? They're the opposite signs, right? So in our formula, it's going to be x minus whatever the h value is for the center, the x value, and y minus whatever the k value was for the center h, k. Okay, and then what about the 36? How's that related to my radius? Equals r squared. You guys see how we squared it to get rid of the square root? That's all that happened. Okay, that is the formula for a circle. So if you know this, it makes circle equations super simple. We like these. Okay, so number 1 says write the equation of the circle with center 5, -2, and radius 8. Okay, so I'm writing the equation of the circle. My center is my hk. So h is 5, k is -2. So my equation is just going to be x minus 5 squared plus y minus a -2. So I write plus 2 squared equals 8 squared, 64. That's it. That's your answer. Easy, right? Yes. Just always know there's always a twist, right? Okay, so next one. So number 2, so it says write the equation of the circle with a certain center, and now it says it goes through another point. We don't have the radius. Do you guys remember back in Algebra 1 when I gave you guys, like, I didn't, I wasn't an Algebra 1 teacher, but when someone gave you the slope and they said, oh, but it goes through the point 3, -4, and you were like, okay, I have y equals mx plus b, and I know m is 5, and then you kind of panicked for a second. You were like, but I don't know b. What am I going to do without b? Well, what did you guys end up doing? You didn't stop. You plugged in 3, -4, so you plugged in 3 for x and -4 for y, and then you found your b, right? That's not hard. Okay, that's all we're going to do on this next one. So we don't have the radius on this next problem. Okay, so I'm going to set up my equation. I'm going to start with my x minus h squared plus y minus k squared equals r squared. And I know my h and my k. My h is -4, so I'm going to have x plus 4 squared minus a -4. And I'm going to have y minus 11 squared, and then I'm going to say equals r squared. And I'm stuck because I don't know what r is. But what can I do? I can take that point, because I know this point is along the outside of the circle. And temporarily, I can use that point to find r, because it has to make a true statement, right? It has to equal. So I'm going to plug in 5, -1. So I'm going to have 5 plus 4 squared plus negative 1 minus 11 squared equals r squared. So I get 9 squared plus negative 12 squared equals r squared. So 81 plus 144 equals r squared. 225 equals r squared. So what's r?
15.
15. Good. You guys are really good at your squares. All right, now the nice thing is, even if it wasn't nice, like if it was 220, and I was like, oh, the square root of 220, that's not nice. Right? It doesn't matter because in your formula you have r squared anyway, right? So you don't even have to go that extra step and find what r is, unless to ask for it, because you're going to have r squared in your equation anyway. So your final equation is x plus 4 squared plus y minus 11 squared equals 225, the r squared. That's it.
So if we wrote 15 squared.
Yeah, but it's really better to write 225, I think. I don't think I count wrong in the test. This is where the other class asked me to go on a tangent, because I'm talking about a tangent, which is a line that intersects a circle in exactly one point. Double meaning, right? So I'm going to go on a tangent. I'm going to tell you a story about when I was in college. And I had this teacher. His name was Steggy, Dr. Steggemoller. And he was a really old man, probably like 80 years old, really old. And very tall and skinny. He was a runner. He used to wear like running shorts to class. Yeah. So I was behind him one day and I was like, who is this old man in front of me wearing these running shorts? Oh, it's Steggy. The little flappy pants where you could almost see like too much. Yeah. So imagine Steggy, 80-year-old man. Really, I'm telling the Steggy story. So Steggy used to draw circles, and he was like amazing. Apparently, there's competitions for circle drawing. Did you guys know this?
Yeah.
I didn't know this. So he used to. I can't do it on this little like machine thing.
Oh, does it where you just like get his arm straight?
Yeah. So on the whiteboard, he would put his arm straight. He'd be like, you have to say it just like him. Here we go. Here we go. Here we go. He had like a southern accent. So you put his hand there, and you'd be like, all right, here we go. Here we go. Here we go. And you go, and it would be the perfect circle every single time. Mine is terrible. This does not look like the perfect circle, but you know how to do those circles. No, so we could have a competition if we have time at the end of class. So like I said, he would put his hand on the whiteboard and he would go shoom really fast. Here we go, here we go, here we go. And you draw perfect circles. Yes? We will have one at some point. I always have a circle contest every year. Oh, you did? Oh, challenge accepted. All right, so anyway, so number one. So let's think about things we know about tangents, not the tangent that I just told you, but a tangent of an actual circle, like the word tangent in geometry. If you guys remember, the tangent to a circle, tangent touches, secant slices. That's how I always tell my geometry students whenever I teach that class, which I never do here. I should teach geometry at some point. No. All right. So anyway, tangent touches, secant slices. So a tangent just barely touches the circle in one single point. That is called the point of tangency. Now, if you draw the radius in from that point of tangency, it ends up being 90 degrees. Guys, you are always just messing with each other. So let's say the slope is, I don't know, -4/3. What would the slope of the tangent line be then? If I had -4/3 for this slope? It would be 3/4, right? It's the opposite reciprocal because they're perpendicular to each other, right? They're perpendicular slopes. So we're going to use that. So in this first example, it says we have x squared plus y squared equals 29. Where's the center for this circle? There's no like x minus anything squared, right? It's 0, 0. It's like x minus 0 is squared. So at 0, 0, I don't know how to draw square root of 29, but I do know that it goes through the point 2, 5. So I'm going to draw that point in. And then I'm going to estimate. So here we go, here we go, here we go. It's funny, isn't it? It's funny. All right. And then I draw my tangent line in. So it just barely touches. And it has the condition that it has to be perpendicular to the, oh, mine's not very good. Mine does not look perpendicular. It has to be perpendicular to that, to the radius, right? Through the point of tangency. Do you guys have that? Yours is probably drawn much better than mine. No? All right. So what is the slope of the radius line? Can you count it? Up 5/2. Do you guys see how this slope is 5 over 2? What is the slope that says 5 over 2? What is the slope of this line then? Negative 2 over 5, correct. Now we could find the equation of the line pretty quickly if we knew the slope and the y-intercept, but we don't know the y-intercept. So what do we do then? We know that it goes through the point 2, 5. So we have y equals mx plus b. You could do it that way. Or you could even do the one that I taught you last semester, y minus y1 equals m times x minus x1, whichever one you want to do. It doesn't matter. So let's say I plug in here. So I have y minus y1 is 5 equals m times x minus x1 is 2. And I solve for y, so I get negative 2 over 5x plus 4 over 5. And then I want to add this 5 to the other side. So if I add it over, I'm really adding 25 over 5. So I get y equals negative 2/5 x plus 29 over 5. That's your answer. Every year, everybody's like, oh, does that 29 have anything to do with the original equation, 29? Yeah, kind of. But it's really only when it's like centered at 0, 0. So don't get excited and think you're always going to have that. Yeah.
How do you know the m was 5?
Because I counted. I said it went up 5 and it went over 2. Like counted the slope, rise over run. You could have also found the slope between 0, 0 and 2, 5. All right, so let's try a harder one where it's not centered at 0, 0. Draw it out. The sketch really does help on these. I know some of you guys don't like to sketch things out, but they really help. Okay, so I have 1, negative 2. My radius, so that was my center, was 1, negative 2. My radius in this case is 5. Do you guys see it? 25. Square root is 5. So I'm going to go up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I go in each direction. 1, 2, 3, 4, 5. And I draw my circle in. Okay. We want the point of tangency at the point 5, negative 5. Somewhere around there. So in order to find that, I'm going to draw in the radius, which I know is going to be perpendicular. And it's going to, that center was at 1, negative 2. So you can count your rise over run if you want to again. So if we're if we're starting at negative 2, how much am I going down and over? So I'm going down 3 to get to the negative 5, right? And I'm going over, if I was at 1, I'm going over 4. Do you guys see it? So it's negative 3/4. So that means the slope of the tangent line is positive 4/3. Do you guys see how I got that? Counting rise over run. Remember that from Algebra 1? I know that's a distant memory. It's been a long time. All right, so we have m equals 4/3, and we have the point 5, negative 5. So y minus y1 equals m times x minus x1. So I have 4/3, x minus x1, so x minus 5, y minus y1, y minus a negative 5 is plus 5. Solve it out. So I get 4/3 x minus 20 over 3, right? That's like 5 over 1 times 4 over 3. And then I'm adding the 5 over. When I add 5, I'm adding 15/3, right? Common denominators. So your final answer is y equals 4/3 x minus 5 over 3. Yeah.
Isn't it supposed to be subtracting x over?
Oh, did I add? Oh, darn. Oh, golly gee. I missed it. 35. So you should get 35 over 3. Thank you. Caroline gets a point.
Yes.
Oh, they will be. But I corrected it. See, YouTube viewers, you could get a point. Oh, no. They know. I used to have a student who had a broken back, and she took the entire Algebra 2 course online. Like, she would watch the videos. She'd be like, it was so painful because I would see the bonus points. I would know that you'd made an error, and I'm like, oh, it's right there, it's right there. And she wouldn't be able to get the bonus points. Sad story. I know, rough. All right. I have several people that have watched an entire year of Algebra 2. Not even that good at this school. I have, like, my cousin's kid like, watched all of my videos. I don't know. Just random people. So hi, random YouTube viewers. We like you. All right. So find the center and radius of the circle with equation x squared plus y squared plus 6x minus 7 equals 0. By completing the square. Do you guys remember completing the square? I see lots of ew faces. Emily's like, ew. Is it completing the square? Ew. All right. So to do this, we want x's. We want y's equals the number. So we're going to rearrange some things. So I'm going to have x squared plus 6x. I'm going to have y squared. And I'm going to have 7. All right, so all I did is rearrange. Do you guys remember completing the square? Yeah? Number, like a little, you might call it a hashtag. Or a pound sign. But it means number. Okay. Anyway. So we're going to do our b divided by 2 squared. That's how we complete the square. So I'm going to take this 6 value, I'm going to divide it by 2, so I get 3, and I'm going to square it, so I get 9. You should be to the point where you can do this very quickly. So I'm going to add 9 on that side, and I'm going to add 9 on the right side as well. Whatever I do to one side, I have to do to the other side. Now, since I just have y squared, I'm done with the y's. Because do you see how that's y minus 0 squared? We're good. That one's already done. Now, the whole point of doing this is so we can get it in the standard form, right? The equation of a circle. So with my x squared plus 6x plus 9, how does that factor? X plus 3 quantity squared, right? And then the y, like I said, was like already y minus 0 squared. Equals 7 plus 9 is 16. That's the equation of the circle. You could also just write y squared. You don't have to do y minus 0 squared. So my center is negative 3 comma 0. My radius is 4. Done. A little bit harder. This one already has the x squared, or the x's together. So x squared minus 2x. We're going to leave a little space. Plus y squared minus 8y. Leave a little space. Equals, I subtract the 1 over, so negative 1. What do I put in those spots? Can you guys complete the square in your head? X squared minus 2x plus 1. You divide by 2, right? Negative 2 divided by 2 is negative 1. Square it. You get 1. So I add there, and I add here. Right. Remember, y squared minus 8y, so I take my negative 8, I divide by 2. I get negative 4. I square it. 16. 16 plus 16. So I have it. I write something squared plus something squared equals negative 1 plus 1 is 0 plus 16 is 16. Because whatever you do on one side, you have to do on both sides. You have to keep your equation balanced. So if I added the 16 here to create my perfect square, I have to add it on this side too. I did my b divided by 2 squared. So remember, I took my negative 2 divided by 2 squared, and I got 1. I take the negative 8 divided by 2 squared, I get negative 4 squared is 16. Add those on both sides. Remember the complete square now? So I get x minus 1 squared, and I get y minus 4 squared equals 16. So my center is 1 comma 4, and my radius is 4. Done. Get it? Easy. All right, number 5 we're actually going to skip, because number 5 is just like what we've already done before. This one will take me like 2 seconds, so hang on. We're going to do number 6 so you can do your homework. So number 6, it says find the equation of the circle with center 4 comma 5 that's tangent to the x-axis. Whenever it says this, draw a graph. So if you have 4 comma 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, it's right here. Tangent means it just barely touches the x-axis. Don't worry about the rest of your curve, but know that it's going to touch right down there. Does that make sense? You're going to have part of your circle just barely touching the x-axis. How big is your radius then? 5. Does that make sense? This is your center, 4, 5. So your equation of your circle, you do your x minus h squared plus y minus k squared equals r squared. So we get that. So whenever I say tangent to the x-axis or the y-axis or whatever you want to draw it out. What if I had said tangent to the y-axis? What would my radius be then? 4. So you'd have 16 at the end, but otherwise it'd be the same. All right, questions?